Yes, is it recording? Yes, it is recording. This is the second recording, so this is a class. There we are. So today we'll be looking at trigonometric functions. Still on trigonometric functions, right triangle approach. So if you go to your study guide, you'll notice that the last two sessions of chapter 5, we were not doing them. Did you see that? Guys, or you're not or you're not even approaching your study guide?
I won't lie to you, me, I've been studying the book, and that's a dangerous mindset, I know.
Yes. So if you go to your study guide, I'm telling you, let me give you a secret. Nah? This is how I set my exam. I go to the study guide, I look. I go to the assignment, I look. I go to the textbook, I look. That's how I start.
I'm on the right track, boss. Thank you.
Yes, that's it. That's it. If you even look at my past question, I go to the question to the exam, I look. I don't go somewhere else and go and find from a magical. No, I go to those three things. I look and I'm like, oh, this one says this one is using the value of 2. Then I sometimes use the value of 3, and then sometimes I reconstruct a question from that question. You know, that's how I do it.
True.
So angle measures. Angle measures, these are objectives of this section. Angle measures angle in standard position, length of a circle, area of a circle, circular motion. Angle measures. Huh? There we are. They say an angle AOB consists of two rays, R1 and R2, with a common vertex. This over here, that corner there, is a vertex. Your elbow is like a vertex. You see your elbow, your hand. You look at your hand. That's an elbow, ne? If you look at your hand, if you move in and out, that elbow is the vertex. And then one part of the hand is the R1, and the other part of the hand is R2. Especially the moving one, it's R2, right? The one with fingers, it's R2. Then that side, we call it the terminal side. And this side, we call it the initial side. Now, if you start moving, let's say all of them, R1 and R2 starts here. If you are moving in this direction, we say we are moving in counterclockwise direction, then your angle will be positive. But if you are moving the blue line in this direction, meaning that you end up here, then you're saying what? We are rotating clockwise. Are we all together there?
Yes, ma'am.
Yes, ma'am.
Now they say in this case, R1 is called the initial side, R2 is called the terminal side of the angle. If the rotation is counterclockwise, some texts will refer it to as anti-clockwise, then the angle is considered to be positive, and if the rotation is clockwise, the angle is considered to be negative. You'll notice that if you understood your work previously, especially in chapter 5, it'll be easier for us to continue from here. Are we all together on the slide?
Yes, ma'am.
Yes, ma'am.
Let's start here. Yes.
I have a question. Sorry, it's not about this. It's about 5.5. Are we not doing 5.5, the modeling of harmonic motions? Aren't we doing it? We're not going to do it.
If you read your study guide, it says 5.5. You would redo this in future, so you don't have to do it now. That's what your study guide is saying.
So my only concern is just only 5.1 up until 5.4.
Yes. So guys, the reason why I'm saying that, go through before you study section, go check if your study guide says study it, because some of you studied sections that are not supposed to be studied. So you're wasting your time. So your study guide is telling you what to study and what to not study. Now in this case, R1 is called the initial side and R2 is called the terminal side of the angle. If the rotation is counterclockwise, the angle is considered positive. If the rotation is clockwise, the angle is considered negative. Now, the measure of an angle is the amount of rotation about the vertex required to move R1 into R2. Did we get that one?
Yes, ma'am.
Thank you.
Yes, ma'am.
Intuitively, this is how, please take into consideration the word measure. Intuitively, this is how much the angle opens 1 unit of the measurement from the angle in degrees, right? An angle of measure 1 degree is formed by rotating the initial side 1/4 of a complete revolution. Meaning, remember that a complete revolution has what? 360, right? So if you're starting from here, then 1 degree is moving from this initial point up to somewhere here. That's your 1 degree. Then it means you have rotated up to here. So this is R1, this is R2. That's what they say. That's you have taken a portion of the pi. Remember when you were doing pi, you were using degrees. So you're taking a portion of the pi. So meaning that you're taking 1. In calculus, listen to this. In calculus and other branches of mathematics, a more natural measure of measuring angle is used, which is the radian measure. Are we all together?
Yes, ma'am.
Thank you. So they're saying forget about degrees. Now we're talking about radians. Now, definition of a radian measure. If a circle of radius 1, before we go to the definition, I see something. Remember in Euclidean, you had something like a circle like this, right? If I draw a line from here to here, what do you call that line?
I think a segment.
Oh,
The line. Not the line segment, the line.
I think
Is it diameter, ma'am?
No.
It's not.
It's a chord. Thank you. It's a chord. Do you remember that one?
Yes, ma'am, from circle geometry.
Yes. So if you draw any line from here to here, here to here, not from the center, any line from here to here, that's a chord. Do you remember that one now?
Yes.
Yes,
Now, if you take, okay, so let's say I've drawn a line from here to here. What do you call this part here? This shaded part.
Is it not the region?
What region? It has a name. That part that is divided, that part when you draw, after drawing that chord, what do you call that part? I want you to go and check. That's your homework now. Now, if I draw a line from the center, line from here, and it passes through the center, what is that line?
the diameter.
Diameter.
Well done. And half of a diameter is what?
The radius.
The radius.
Thank you. Now, if I draw a piece like this piece here, what is this piece here?
An arc. It's an arc.
There we go. Thank you. So now they say if a circle of radius 1 is drawn with a vertex, remember we said a vertex is this part.
Yes, ma'am.
So this is R1, this is R2. So they say that if a circle of radius 1, do you see now we're still on unit circle, guys? Circle of radius 1 is a unit circle. So they say if a circle of radius 1 is drawn with a vertex of an angle at its center, meaning its center here. Do you see that? Now, since this is a center, this one is radius 1, this is a radius, and this is also a radius.
Yeah.
Are we all together?
Yes.
Thank you.
Yes.
So then the measure of this angle, listen to this, then the measure of this angle in radians is the length of the arc that subtends the angle. Does that make sense?
Can you please repeat that, ma'am?
So they're saying that if you have this angle, right? This angle over here, then the measure of the angle in radians, it is the length of this arc. Are we together?
So the radius
The length of the radius is equal to the length of the arc.
Not the length of the radius. The measure of the angle. So
Oh,
this theta here is equals to, in radians. Now, I don't want you to confuse yourself here, because I did when I was looking at it the first time. The angle is not the length of the arc suspended by the angle, by these radiuses. It's not the length of this. Are we all together? Right?
Yes, ma'am. Yes.
But it is the length in radians. So meaning that if the length from here to here is 2, right? Then the angle is 2 rad.
okay.
That's what they're saying. That's what they're saying. They're saying that then the measure of this angle in rads, abbreviate, is the length of the arc that subtends the angle. This is the arc that subtends the angle, meaning this is the arc that here, where the red, this is the arc that touches these two parts, which form R1 and R2, let's say, of this angle. Are we all together?
Okay.
Yes, ma'am.
Yes, ma'am.
Now, look at this. The circumference of the circle, meaning the distance from here. Let's start here. So if I was moving from here to here, I go around and I come to there. What would be the arc length?
Two pi, two pi. It's going to be the circumference, man.
Yes, it's going to be the circumference, meaning that now the angle will be what? The angle will be 2 pi rad. Are we all together?
Yes, ma'am.
Yes, ma'am.
And if we, okay, before we go to the, if we do the what, we have to meet the rad first. So then they say the circumference of the circle of radius 1 is 2 pi. So a complete revolution has a measure of 2 pi rad. A straight line has a measure of pi rad. And a right angle has a measure of pi rad over pi over 2. So we are saying that sometimes instead of using degrees, we use what we call radiances. And this is how we then measure radiances. Now, an angle that is subtended by an arc of length 2, meaning that from here to here, the length is 2. Ne? The unit circle has a radius of, okay, so what am I saying now? An angle that is subtended by an arc of length 2 along the unit circle has rad measure 2. Does it make sense? So this angle here
Yes.
will be what? This angle here will be 2 rad. Because the length, the arc length is what? The arc length is 2. Are we all together?
Yes, ma'am.
This one is 1 rad. Because here, from here to here is what? From here to here is actually 1 rad. The length, I mean, the length of the arc length is 1. And do you notice that from the origin to the circle, that's a radius, right?
Mm-hmm.
From the origin to the circle, that's radius. And now, from the red point, this red point is also 1. Do you see that?
Yes.
Yes.
So that's the radius as well. It's the same length as the radius, but on a second. Do you see that?
Oh.
Okay, I'm highlighting that
Wait,
because
can you
there's
repeat that?
okay.
Can you repeat that,
So,
ma'am?
do you see that from here, from the initial point here to touch the circle, we call that what? A radius, isn't it?
Yes.
Yes.
Now we say, what if we then move a length of the radius from here? to there, but along the unit circle, that gives us 1 rad. That's 1 radius.
Mm.
Does it make sense?
So wait, ma'am. So you are saying from, let's give those names, ma'am. From it's 0, and then the point that is 1. It's, let's say it's A, and then you are saying from 0 to that point in the circle is 1, and then when we paste that distance in the circle, which is,
Yes.
it's going to be a chord, then it becomes 1 rad.
Yes. We know our radius is 1, right? And then we move another distance, which is also 1, the same as the radius. That's 1 radius. Do you see that? Look at here. Here they fit 2 radius. The first one is the same distance as the radius. And the second one is also the same distance as the radius. So there are 2 rads in there.
Yeah.
Make sense?
So, ma'am, it's not from R1 to all the way to R2 in that side. It's 2 rads.
Yes. So it means
Okay.
you fitted, let's put in quote, you fitted 2 radiuses in that arc.
Okay.
Yes.
2 arrows of 1 red.
You're saying what?
2 arrows of 1 red. The measures of it's like 2 times the 1 red arrow thing.
Yes.
Yeah.
Now they say the relationship between degree and radiances. Are we all together? This is the relationship. So if you have 180 degrees, that is pi rad. And if you have 1 rad, it means you have how many degrees? You have 180 over pi. Now go on your calculator and say 180 over pi. What do you get? And we know that 1 rad is something like this, according to what we have done there. So it's something like this part, which is 1. So we took the radius here within the distance of the radius from on this arc. That's 1 rad. So 1 rad is what in the calculator? What do you get in degrees? So if you say 180 over pi, what do you get, guys?
57.29.
57.29 degrees, isn't it?
Yeah.
Yes.
So it does make sense that this point can be 57.29 because it's before 90. Do you see that?
Yes, ma'am.
Yes. Does it make sense now?
Yes, it does.
Yes, ma'am.
So meaning that from here, if you fit 2 radiuses, let's say you call them radii, right? If there are 2, so and more. So if you fit a radius, the distance of a radius from here, we know it's 1 from here to here, and fit another radius from here to here. We can see this one has passed 90 degrees. Meaning if you say 2 rad, it means you are saying that 2 rad. So 2 rad will be equals to 2 times 180 degrees over pi. And you'll notice that if you times this will be over 100. And that's true. That's where your 2 rad is. So this is 100 and something degrees. But now we are using rads as measures. Are we all together?
Yes.
Yes, ma'am.
Yes.
Yes, ma'am.
So basically, it's like we're fitting radiuses on that arc length. That's what we're saying. So now they say we did how to convert degrees to radius by multiplying by pi over 2, isn't it? So I won't repeat that. Guys, you remember that one?
Yes, ma'am.
Yes, ma'am.
Yes, we do.
Now to convert radius to degrees, we multiply by pi over 8. And lucky you, they want us to do that. So they say that express 60 degrees in radians. So they said, so we go back and said, we want to convert, we have a degree we want to convert, so we have to multiply by pi over 6, pi over 180. So you say 60 60 times pi over 180 degrees. This is equals to 60 pi, and we know 180 is the same as what? Is the same as 3 times 60, isn't it, guys? Which is equals to this and this. They form a 1, so this is that.
Yeah.
Yes.
Mhm.
So we have moved from degrees to radians. And we did that in previously. Are we
Yes,
all
ma'am.
together?
Yeah,
Yes.
together, ma'am.
Together, ma'am.
Wait, ma'am. Where did the 60 come from? Oh, no, never mind. Okay, I'm looking at the full calculator. Never mind.
Okay, no problem. Now, so they say express pi over 6 rad in degrees. So you see here, you multiply by 180. It means you multiply by the reciprocal. So it's pi over 6 times 180 degrees over pi. So this is equals to pi times 180 degrees over 6 times pi. And we know that 180 is the same as, so we say pi, 180 is the same as 6 times what? 60. What am I saying, guys? Please help me here. 180 is the same as what?
It's
60.
Times 3.
60 times 3, isn't it?
Yeah.
Over 6 times pi. And if we notice here, we say pi and pi cancel. So then we know the reason why I'm doing it like this. I just want to show you how to solve without using a calculator, right? So pi and pi
Yeah.
cancel. So meaning that you remain with 60 times 3 over 6. And 60 times 3, you can also write it as 60 times 10 times 3 over 6. What am I doing now? Am I losing myself? I'm losing my mind.
It's okay, ma'am.
It's okay, right?
Yeah.
So the pi and pi, they cancel, ne? And then you have 6. So you have 6 times 10 times 3 divided by 6, and that 6 and that 6 cancel. It means you have 10 times 3, so that's 30 degrees.
Ma'am,
Yes.
there's even a simpler approach for number B, ma'am.
From number B, I could see that 60 180 divided by 60 is by 6 is 3.
30.
It's 30, yes.
Yeah, it's 30. Sorry, 30.
Yeah, you don't have to do it like this. I'm just showing you how I would do it without the calculator. Because sometimes you might be panicking and you're like, oh, what is 180 divided by what is 180? Yeah. But if you can see that it's 30. But by now, guys, you know that pi over 6 is 30, pi over 3 is 60, pi over 4 is what? Pi over 2 is what? Isn't that you know?
Yeah.
Yes. Thank you. Are we all together on the slides?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Okay, that's what we got. So they refer to as red. Note on a terminology. A note on a terminology. We often use the phrase such as a 30 degrees angle to mean an angle whose measure is 30 degrees. Are we all together?
Yes, ma'am.
Thank you. Also, for an angle, theta, we write theta is equals to 30 or theta is equals to pi over 6. To measure the measurements of theta is 30 degrees or pi over 6 rad. When no unit is given, the angle is assumed to measure in radians. Was that clear? Because it's in red and it's bold. It's a bold red. It's clear now? Okay, let's move on. Angles in standard position. Did I lose someone there? Because it looks like we're moving to the next objective. This one will be very
Makes sense.
This one will be very fast because it's similar to this one, and I'm sure next one will be very fast because it's similar to what we have been doing all along. So we papered and covered the coming sections in the previous sections. So an angle in a standard position if it is drawn, so they say an angle is in a standard position if it is drawn in the XY plane with its vertex at the origin, the corner at the origin, and its initial side on the positive x-axis. At the origin and its initial side on the positive axis. Does it make sense? Guys?
Yes, ma'am.
Could you repeat that again, man?
Makes sense, ma'am.
So they're saying that if I tell you draw an angle on a standard position, they mean that you started here on the positive xy and you started moving like this, right? Or you started
anti-clockwise, yeah.
here on the positive, where the vertex is on the initial, or you moving like this. Then you say that angle is on a standard position.
Okay, makes sense.
So here they are just showing these angles where they started. They always start, the corner is always at 0 and they rotate. The vertex always is at 0. Then you say it's a standard position. The rotation started at x, positive x-axis, meaning this line here, that part, positive x-axis. So it either rotated anti-clockwise or it rotated clockwise. Now, two angles in a standard position are coterminals if their sides coincide. Does that make sense?
Elaborate,
Guys?
ma'am.
No, ma'am,
So
please
the
explain.
you know when you close your hands like this, right? Your two hands, and your thumb is on top of your thumb, unless someone else here is different. I don't know. Your thumb is on top of your thumb, isn't it? Your middle finger is on top of your middle finger. Your little finger is on top of your little finger, isn't it?
Yes.
Guys? Then you say those are coterminals.
Okay, ma'am.
So meaning that, let's say you start with the first angle and you are here and you started rotating from here to here, right? And then let's say you come back, you start another angle, let's call this angle theta 1. And you start another angle, this time you rotate, and come on the same position and also stand on top of this one and then call it a theta 2. Those two angles are coterminals because they coincide, they're on top of each other basically, in simple terms. So here they're saying figure 5, the angle in A and C are coterminals. I want you to understand, because in the exam, if I take out something like this and say, which two angles are coterminals here? And then you don't know. Do you see that C? If I move this thing and put it on top of this thing, they will all be here.
Yes, ma'am.
So that is, those two
Correct.
angles are coterminals. Even though this one I
ma'am,
moved. Yes?
So what I'm understanding is if they both meet at the same point but in opposite directions, they're considered as a co-terminal.
Not in opposite direction. They can be the same direction, meaning that an angle can start from here, move completely, keep on moving 10 times and come back on the same position. And they touch each other the same way your hands are touching each other. Then they are coterminals.
Okay.
Not necessarily in the opposite direction.
But
they
it
can
has
move in
to
the
be-
same direction. One can move. For example, if I run 2 meters and I stand there, you keep on running and come back and stand where I'm standing. It means we are coterminal.
The direction doesn't matter.
Yes, direction doesn't matter.
So
But
so
it
as long as
always
they're in
has
the
to start
same
on the
point, then,
positive side.
Same thing.
Okay.
oh,
Do you understand? Same thing. As long as whether you have been running from Cape Town to Cairo and then you come and stand next to me and you were the same. Basically, you are saying we are standing in the same position. We are coterminals. So those angles are coterminal. Direction doesn't matter. Are we all together there?
Yes, ma'am.
Thank you. Now they say find angles that are coterminal with angle theta. Angle theta is equal to 30 degrees in standard position. So can someone just give a picture? Which angle will be coterminal with angle theta? What do you think? You know angle theta,
What
30
angle?
degrees. So let's start here first. We know 30 degrees is somewhere here. Oh, I forgot I can choose colors.
Ma'am,
Yes.
can't I choose 150?
Okay, 30 degrees. Let me choose. I want you to, you said you are choosing 150.
Yeah, 150.
So I move from here to here. This is theta, isn't it? So 150 is 0. Because here they put in degrees. Wait. 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So if you are saying 150, do you see that you'll be somewhere here?
No, yeah, ma'am, it won't work. I see it now. Yeah, it won't work.
So
390.
which means
390. 390.
390.
Yes.
Yes.
Positive or negative?
Positive.
Positive.
You need to be very careful. Positive or negative?
Positive.
Positive.
Thank you. So 390, let's see. I'll start from 0, isn't it? I'll be here. My arm will be here, isn't it? It starts here. So I go there. Then I'm 360, isn't it? 360 plus 30 degrees is what? 390, which means I'll be here. So I'll be on the top of this.
So is it wrong to also say it's 330 but on the negative side?
330.
Correct.
Okay.
330 negative side.
Yeah.
Let's see. From so here it's negative 90, isn't it? So then I'm negative 180
minus 30.
This is what's this? 390. You're saying what? 330?
Yes, ma'am.
330 on the negative side.
330 on the negative side. You're right. So you stand here. So meaning that you have moved like this. So you are correct. So it's someone said 390. Someone said 330. Negative 330. 330 degrees. You are right. But do you see there are two options here? Guys? And I have more options as well. So how can we generalize this? How can we generalize this? Because it means that if there's 330, there's 390, there's 330, I can have 720, for example. So how do we generalize this?
I think I understood it in a way of like we're saying complete revolution minus the angle that we have.
Okay, so let's start with the angle. Always start with the angle because you want to form a relationship.
So we say 30 degrees minus 360. That's when I will get minus 330.
And
then we start with the complete revolution, 360 minus 30. Then we get, we added the complete revolution. Then we get 390.
Thank you. So it's 30 degrees plus 360 degrees. Do you see that? Guys?
Yes.
But we haven't generalized it because someone can say, me, I like moving 7 times. So you get and then they end up here. So meaning to generalize it, we'll say what? We'll say theta is equals to 30 degrees minus 360 degrees times n. And theta is equals to 30 degrees plus 360 degrees times n, where n is an integer. Meaning that if where n is an integer. Meaning that if I choose, I don't have to write it even like this. I can just say theta is equals to 30 degrees plus 360 degrees times n. I can use 1 like this. Why I'm saying that is because if I choose n minus 1, Do you see that it will be equal to, it will be n is equal, theta will be equal to n minus 1 will be 30 degrees minus 360 times, 360 times negative 1 becomes negative 360. It means we find this one. Do you see that?
Yes, ma'am.
If I choose n to be 1, then it means this becomes positive. Then we find this one. So the general term is this one, or the one with the negative, and n can be positive or negative. Are we all together in that point? Or did I lose someone? Guys?
We are together, ma'am.
Can I have 3 yeses?
So n can be any number as
Yes,
long as it's the general term we use.
Integer. Integer.
Yeah. Okay.
Yes. Integers are, you know, when you're counting, you say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, isn't it? You don't have
Yes.
5.5 cows. Yes. So then put negatives on those numbers as well. So put positive and negatives. Those are called integers.
Okay.
Yes.
Yes, ma'am.
So whole numbers, positive and negative. Yes. So let's see. Now to find positive angles that are coterminal with theta, we add any multiple of 360. Well done. Then we get, do you see that someone can decide to move once and get 390? Someone can decide to move twice and get 750. Our coterminals with theta is equal to 30 degrees. To find the negative angles that are coterminal with theta, we subtract any multiple of 360. That is what we said, 330 degrees and negative 690 degrees, meaning that the one negative 690 degrees, they move twice in a counterclockwise direction. They are also coterminal. So do you see the movement? Look at that. Look at 30 degrees, look at 390, and look at negative 330. They all look the same in the same position, regardless of their movement. Are we all together?
Yes, ma'am.
So basically, for example, in real life situation, we're saying that we are all coterminals because we are from different cultures and different backgrounds, but we end up in the same MAT1510 class. So MAT1510 class is just making us coterminals, if we're putting it like that. Now they say find the positive angles that are coterminal with theta. To find positive angles that are coterminal with theta, we add any multiples of 2 pi. Then we get that, we get, sorry guys, we are answering number B. I didn't see that. Do you see when you understand, you don't even have to go through the whole answer. Hey guys, if you understand your work, you don't have to go through all the whole answer. It just becomes easy.
So, ma'am, can I ask, sorry, would it always be a 360 case, or it will differ on where the angle is in either quadrant 1 or quadrant 4?
I think it will most definitely differ, you know. It will most definitely differ because if then you are on a quadrant, you need to visualize it. As I said, it's important to visualize it. Does it make sense?
Yes, ma'am.
Yes.
Thank you.
You're welcome.
But wouldn't you still have to go to the reference angle even if it's different from like other quadrants?
Yes, you still, even moving the reference, that's true. Because if I'm at, let's say I'm at, what is 90 plus 45? 130 degrees. You see, I have to move. Yeah, it's always like that. It's like we're adding to the reference, basically. That's what I see. No, we'll look at examples. Let's not just conclude. Let's look at examples and see what it says. Even the revision, you can write it down so that we can cover it in the revision class. Okay, now we have pi over 3. What is pi over 3, guys, in degrees?
60.
60. So 60 is here. We know, oh, sorry. We're pi over 3. This is pi over 3. So meaning that it still makes sense to move from here. You can, so it will be 360 plus pi over, what's this? 360 plus pi over 3, isn't it? From here, it does make sense still, right? It's like we're doing it the same way as we did the above. Does it make sense, guys?
Yes, ma'am.
Yes, ma'am.
So meaning
Yes,
that
ma'am.
here we're saying pi over 3 plus 2 pi, and we're also saying pi over 3 minus 2 pi. In this case, the general term will be, the general one will be pi over 3 minus 2 pi, where n is an integer. Or normally, in most cases, they like saying plus 2 pi times n. Okay?
So, ma'am, quick question. So, this case you gave the answer in radio. Is that like so? What is my question? Can I do the answer in degrees and then convert it to radio afterwards?
You can.
Okay.
Because this is just pi over 3, that's 60 degrees. This is just the same as 60 degrees plus 2 pi is 360 degrees times n. You can, but you need to remember to reconvert it back, because as they said in the red, highlighting that if you are not given angles when no unit is given, you should assume we're talking about radiances here.
Okay, will do, ma'am.
So in this case, it is radiances, yes. So then we say, okay, we did this one. You see, if you understand, it becomes nicer. To find positive angles that are coterminals with theta, we add any multiples of 2 pi. There we go. It's the same question. And then to find negative angles that are coterminals with theta, we subtract any multiples of 2 pi. There we go. Do you see that? So then all these figures in 7, they are coterminals. Length of a unit circle. What do what are they saying? Length of a circular arc. What do you think they're talking about here?
The length of the arc.
Isn't it the distance of the distance of the arc?
Thank you. The length, this one, this part here. From here to here, what is it? That's what they're talking about. And now I'm plugging the length of a circular arc in a circle of radius r. Now, do you see that we're saying radius r? We're not saying unit circle, guys. Are we all together?
Yes, ma'am.
So all along we've been talking about the unit circle, the unit circle, this, but now we're saying we have a circle and we have a radius r.
Okay.
Then here we were saying, let's go back. We have a circle and our radius is 1. Do you see that? Our radius is 1. And here, how many radiuses are we able to fit? Radiuses or radius we're able to fit in this arc length. Does it make sense?
Yeah.
Now we are saying we don't know the radius. If we knew the radius, look at this. I want to show you something. If we knew the radius, what's this? If we knew that the radius is equals to 1, then S is equals to theta, red. S is equals to theta.
Okay.
Does it make sense? That's where the definition comes in that says, this definition over here, that says, if a circle of radius 1, if a circle of radius 1, then S is equals to theta. Do you see that? If a circle of radius 1, then the measure of that is what? Is the length, that is S red. Does it make sense now, the definition?
Yes, ma'am.
Thank you.
Yes, ma'am.
Now we are saying we don't know the radius, so we can't assume that the circle is 1, right? We can't assume that S is equals to 1, and we can't assume that theta is equals to S red, because the radius is not 1. In this case, we can't assume that if we draw a circle like this with the radius 1, here we have fit maybe 2 radiuses here and here. We can't assume that. We don't know the radius. So meaning that now, because we don't know the radius and we're not dealing with the unit circle, we are saying a circle of radius r. So we're just drawing a circle and saying this is r. The length, arc length, meaning let's say this is another r. And then here, the arc length, this is s, guys. That's called what we call the arc length. The length of the arc, or the arc length. That subtends this central angle of radius theta, meaning that here, off angle, someone is disturbing me. That's why I'm not able to read what's written here, guys. Please mute. So in a circle of radius r, the length is of an arc that subtends a central angle of theta. Radians is this one. So meaning that this is theta and it's in radians. Are we all together? Theta is in radians. So meaning that if we want to solve the arc length, we'll say S is equals to R times theta. Now solving for theta, then we can be able to find theta. Then theta is equals to S over R. Are we all together?
Yes.
Yes. This makes sense.
Go. So this formula allows us to define radian measures using a circle of any radius, r, not specifically a, r is equal to 1, but any radius, not specifically a unit circle. So now radian measures of the angle theta now is what? S over r. So meaning that theta is equals to S over r. If we knew that r is 1, meaning that we're dealing with the unit circle, then it allows us to go to that definition and say that your theta is equals to the arc length read. That makes that definition true. But now the theta changes because we do not know what r is. So meaning that that formula allows us to get how, what's this? It allows us to get the r. Now, the radian measure of theta, of the angle theta, is S over R, where S is the length of the circular arc that subtends theta in the circle. Now, remember when I was talking about radiances? Now they say the radian measure of theta is the number of radiuses or radii that you can fit in the arc that subtends theta. Does it make sense now?
Yeah.
Radius does it mean that the radius is more than 1 now?
Yes.
More than 1.
Now they are asking, yes. Remember we said that theta, if we know this is 1, and we know that from here to here it's 1, it means how many radiuses did you fit here?
100.
100. Okay, good. So now we still know this is 1. And we know that, okay, let me choose a different color. We know that I move from here and this is 1 as well. And actually I moved to there. And this is 1 and this is another 1. And you know this is 1. How many reds did you fit there?
2 red.
2 red. And then your theta was equals to 2 red. So meaning that now this new formula over here that we are using actually tells us, remember you'll get answer, let's say you get 5 and then your units will be red. It means how many radiuses have you fit on this arc circle? That's what they are saying. So your theta actually gives you how many radiuses you have fit on this arc circle. I mean arc here. And here, it also gives you how many radiuses have you fit here on that arc, subtended by these two R1s, R2. Does it make sense now?
Yes.
So then they say the radian measure of theta is the number of radiuses that can fit in the arc that subtends theta, hence the term radians. Now you know why they're saying it's in radians and not degrees. So it means you are busy fitting the radiuses. Are we all together?
Yes.
Yes.
Thank you. So now find the length of an arc of a circle with radius. So R is equals to 10 meters. that subtends a central angle of theta is equal to 30 degrees. And this is a question in your assignment, guys. So R is equals to 10. So this is assignment 5, isn't it? Theta is equals to 30 degrees. So what is the formula for the arc length? So if you go back, the formula for the arc length is that one. So please help me. S is equals to R theta. Help me to substitute.
30 degrees.
I'll zipper someone. 30 degrees times.
10.
10.
I'll zipper everyone here. Why?
300.
I'll punish everyone here.
Why? Because you said we must use red.
Thank you.
Instead of the
Because
angle.
thank you. Because the definition says that in a circle of radius r, the length of the arc subtended of theta is in red. So meaning that you are supposed to go and change this and make it red. So meaning theta, we know that if theta is 30 degrees and then it's pi over 6. Do you see what you were supposed to do, guys?
Yes, ma'am.
Yes, ma'am.
Thank you. Now, in the exam, I'll give you that option that you just gave me now as one of the options, and most people will get it wrong because they forget to understand their work. So I can give you two options. I can say S is equals to 30 times that, and I give you S is equals to pi times 10. And most people will go for this one because they saw 30 degrees, which is right, but which is wrong because remember this, we said theta should be in what? Theta should be in radiances. And if you're going to substitute what's this degrees, you're not only going to substitute 30, you need to substitute a portion of 30, which is like maybe 30 over 360 times the circumference or times what it's just for a long formula that you don't have to go into it at this moment if you're going to directly submit 30. So this is equals to 10 pi over 6, which is 5 pi over what?
3.
5 pi over 3.
3.
Thank you. Meters. Oh, all together there, guys.
Yes, ma'am.
Yes, ma'am.
Yeah.
Okay, let's move to the next one. The next one says a central angle theta in a radius 4 is subtended by an arc of length 6. Find theta in radians. What are we given here? Guys, what are we given?
The arc
And
length.
the radius and the length of
The
the
arc
arc.
length.
And then we're given the, so
Radius.
this will be equals
Radius
to,
4.
4.
so we know
4
S is equals to R theta, then we know theta is equals to S over R. Then we know theta is equals to what is S? S is 6 over 4,
6 over 4.
which is equals to
3 over 2.
over 2.
3 over
Meters.
2.
Radians.
Thank you.
Radius.
Remember, theta is in red.
Yes.
You see how easy it is, but it will become very difficult because you don't understand your work.
Yes. Yeah.
If you don't understand your
Ish,
look at this.
yeah.
We're just moving. Move. Next one. We don't even go through the exercises. What's this? The solutions, because we know we are right. We know we are right. Now the area of a circular sector. I said, what is this, guys? This. Can you discuss? What is this? What is this? What is this? What is this? And what is the line that goes through? Okay, can I give you 2 minutes to discuss? I just want to Google the picture.
No problem.
Is that okay? Thank you.
Okay, can you label
Okay.
them, ma'am? 1, 2, 3 before you go, so that when we talk, you know which one to say.
Okay. So you have something like this. So there's a line here. Let's call it 1. And inside,
One,
let's call it 2. And the line that passes through the origin, let's call it 3. And then we have 4, 5. This part is 6 and 7. All together.
Yes, ma'am.
Yes,
Okay,
ma'am.
then I'll stop sharing because I don't want to give you answers. I'm sure there's a nice picture that describes this.
Okay. So I think 1, we already find it. It's chord or chort. Depends on how we pronounce it. And 2 is the minor segment. Because
Wait,
it's
guys, I
smaller.
can't see the screen. What is
Yeah,
going on?
the picture's gone. What was 2 again?
Oh, 2 was the shaded area that is between the circumference and the chord. So that small part I think is called the minor segment.
Draw it now. Draw it now, please.
Oh,
Okay. Let's do
just
it.
take a screenshot. No, just take a screenshot
Yeah, screenshot once.
once.
Yeah, guys, technology. Me, I was going to draw. Then I thought, yeah, technology will make you. Hey. I remember
All
my
right.
first time when I taught into a face-to-face, and I noticed people were not taking notes. And then after, when I'm about to raise, no, ma'am, we want to take notes, and I'm like, it's going to take you time. And they took out their phones, and I'm like, yo, knowledge. Okay.
Ma'am,
Okay.
4 is that the which one is 4 and which one is 5 then?
4 and 5, it's
Are the
this.
same thing?
It's this one. Yes. Basically,
Okay.
it's this one. Yeah.
Okay.
Have you
Okay.
drawn so that I Google now?
Okay, you can draw me. Yeah. You can go.
Yeah, I can go now.
Okay.
All right,
So
so
are we agreeing with 2? Are we agreeing with 2 is the minor segment or what?
the shaded region.
Yes. Remember when you divide the circle like
Brenda,
with
you're
the
saying the
chords,
shaded region is what?
the
What do you
small
guys
one,
think?
the small one, right? That one behind the chord. We agree that 1 was chord, right?
Yeah.
So
Yeah.
when you divide the circle with a chord, you have the major segment and the minor segment. Do we agree on that?
Major and
A major and minor. So we have now 2 segments in the circle. The major segment that has got 3/4 of the area, and the small one that has got the minor segment. Then 3 is the diameter because it's cutting the circle in half.
yes.
Yeah.
Then I think 7 is the arc length.
No, is
No,
is
the
the
arc
angle.
length, I think it's 6,
No,
Brenda.
isn't 6 the arc length?
Brenda,
Yeah,
6
6
is
is
the
the
arc
arc
length.
length.
Wait, let me go. Yeah, 6 is the arc length, 7 is the sector. 6 is
Oh.
the arc length,
Yeah, it's
7 is the sector.
theta.
7 is the sector. Then 4 and 5, I think they are the radius, isn't it?
Yes.
Yeah.
Of the sector 7.
So 7 is the sector, 4 and 5 is the radius.
Yes.
Yes.
No, 6.
6 is the arc
Isn't
length.
7?
No,
Isn't 7?
no, 7. Yeah, 7.
7 is that area that is what can I say? It's enclosed with 4 and 5 and 6. So 4 and 5 and 6 they are enclosing 7, which is the sector, right?
Yeah,
Because
okay. Isn't
if you divide your what do you call it? If you divide your circle in sectors, you're gonna have 3 sectors, isn't it? 6 sectors with 1 pi. Then you get 3, then 6 sectors of 1 radian. If I don't know, 4. You're gonna have 4, 8. Just try to cut the circle.
But then 4 and 5, they're the same
Radius.
answer.
Yeah,
Yeah.
4 and 5, they are radius. They are
Yeah,
enclosed
they're
in
both
7.
medians.
Okay.
Let's discuss 2.
The
Two.
shaded
Yeah.
region. Didn't we conclude that?
Me, I'm still saying it's the minor segment, and the one that mem didn't label, the one that is 1, including the sector, the diameter, and the radius, that whole other side, which is not shaded, is the major segment.
Yeah, yeah, we can see it's a lower segment. Doesn't it have like a word for it, like that shaded part? I don't think I've seen that.
I think that is from psychogeometry, that one I can still remember that. I don't know.
Yeah, maybe
Because
like
you
that.
have to have segment in your circle. Then you have the
Yeah,
minor segment.
yeah, but I think she said it's our homework because I think I forgot the
Yeah,
name of
I remember that part.
shaded part.
But I
Yeah.
want it now. Now I
Yeah.
Yeah, we can
Wantable.
say
It's
Mem, we
wantable.
finish. Yeah.
you can say
Okay.
It's
Now
wantable now.
All right,
now
it's due
you are
now.
back, ma'am. Are we correct? You can correct us now. Are we correct in what we were saying?
I need to go back to the notes.
Okay.
Let me not correct you. Let me take you back. Take you to the back. What am I saying? That song says take you to the beach. I said take you.
Kicked on the
Okay.
lines.
Let me just not
Okay.
sing. You know what? Let me just not sing. Okay. Are you ready?
Yes, ma'am.
Okay.
so.
Here, let me share the screen. With the help of Google, I was
It's
able to
even cold.
find
It's called,
what
even coldish.
I wanted.
Oh, yeah, I can't go to Google.
The chord. Ah, all right.
Yes, we got it right, guys.
Yeah, there we go.
Yes, we got.
Wait, guys, where's the minor segment and all of what you were saying, guys? Nina, you were talking about minor segments and all of that.
But segment, round off, same answer.
Round off to the nearest whole number.
Okay, so you see that
It is still a
an
minor
area,
compared to the big one.
you see that an area that is this area, this portion here, if you draw a chord and this portion, you have a portion there, then that is called a segment. Are we all together?
Yes.
Okay.
Yes.
So meaning I can draw it over here as well. So meaning this part here, it's called a what? A segment. Are we all together?
Yes.
Now,
Yes.
here we call it the radius from the origin. Half of the line from the origin to the circle at any point on the circle is called the radius. Now, the line from that starts from one part of the circles, goes through the origin and goes to the next part is called this one is called what? The diameter. Are we all together?
Yes.
Now, this is half of the diameter is called the radius. Are we all together?
Yes.
Now,
Yeah.
the line that divides the circle and the segment is called the what? The chord. Do you see that? That line is called the chord. Now, if you have two radiuses, radii. Let me remind radii. If you have the radii, and me, I'll call them radiuses. If you have the radiuses, you have one radius and you have two radius, and it forms an angle there of theta, right? That part here is called what? A sector. Do you see that? This part.
Yes.
Yes, ma'am.
Where you have the arc, you have the two radii and the theta. It's called the sector. Are we all together? Is this in the mind now?
Yeah, what?
So is it the sector when it's basically 90 degrees or it's that completely separate?
The sector, if there's so if there's a circle like this, ne? And then from the origin, you draw a radius here. From another origin, you draw a radius, and there's an arc that subtends these, then that angle. This will always be a sector.
Okay.
Even if it can be on the other side, I have a radius from this side to that side. I have a radius from this side to that side. Obviously, this will form an angle. And then I have that arc length. So this will be a sector. Are we all together in this building? Of
Yes,
the
ma'am.
MAT 1510?
So what about
Can
the
I go
outer
back?
part?
The what?
The outer part of the circle. I mean,
No,
of
I
the
don't know.
sector.
I think it's called the outer part. That's what the assignment is saying.
Okay.
If we calculate the outer part, yes. I think that's because we normally use the outer part. Do you see that? Okay. Now let's go back to our work.
Ma'am, can I ask,
Yes.
will we need this just
I
in
don't know.
future or now? Like now, will we need this introduction or it's just a warm-up?
I don't know. Let's read.
You
What
need
does it say?
Area of a circle sector.
Did you know what a sector is before we even entered here into the introduction?
Nope.
Thank you. So I don't introduce what we don't need unless we are having a general question. So the area of a circular sector. Does it make sense now? So meaning according to this, we are saying here, radius, theta, subtend, the arc. Do you see that? Now they're saying in a circle of radius r, the area of a sector with a central angle theta, this one here, we know sector is this one here, then its area is equals to 1/2 r squared pi. Do we have pi? Yes, we have. Do we have r? Yes, we have. Now we can be, now you do you see now what, do you see now that you understand what you're talking about? So meaning that it won't easy to cram, isn't it? It's useless to cram because you understand your work. Are we all together?
Yes.
Yes, ma'am.
Thank you. So that's what they are saying. Want this area here. Sometimes they won't say find the area, they'll say find the shaded area, but you know, according to that introduction, the shaded area is called what? A sector. And since it's called a sector, you go and take this star and then this formula, and then you find your solution. All right. Now they say find the area of a sector, meaning you have a circle and then there's a sector, meaning that there's this part. Sorry. There's this part here. We know this is a sector, right? They want that area there. Now, what is the angle? The angle is 60 degrees, and we know that we're not dealing with 60 degrees. We're dealing with what? Theta will be what?
Pi over 3.
Thank you. Theta will be pi over 3, since theta will be pi over 3, and r, what's this? R will be 3. So meaning that the area of this sector is 1/2 r. What is the formula? R squared theta. So this is equals to 1/2. What is my r squared? My r squared will be 3 meter. Ne? So if you say 3 meters squared, that will be 9 meters squared. Theta will be pi over 3. So let me write it here. So this is equals to 1/2 r squared theta. This is equals to 1/2 3 meters squared pi over 3. So this is equals to squared. Squared is outside. So this is equals to 1/2 times 9 meters squared. I'm just writing the units so that we get the right units, but we know that it will be what squared. So this is equals to 1/3 times 3 times 3 meters squared pi over 3. Guys, you know the answer. I'm just trying to, this is 2. So this 3 cancels this 3. Then I'm left with what? Then I'm left with 3/2 pi meters squared. Are we all together there? You don't have to do like me, where you split the numbers. You just have to get the answer. We all together, ne?
Correct.
Yes, ma'am.
Thank you.
Yes,
Let's
ma'am.
see how many. Now it means we need to. So they say to use this formula, we know we don't even have to read this, guys. Let me erase, but because we understand our work, as I said, you understand it saves a lot of time. Because someone will do 20 million past papers and still fail the exam because they didn't understand their work. So it saves you a lot of time. So meaning that to use the formula of the area with pi over 3, I read like that because we already knew what we were doing. That's the area, is that. Do you see? Understand your work? Circular motion. Suppose a point moves along a unit circle as shown in figure 12, right? There are two ways to describe the motion of the point. Linear speed and angular speed. Linear speed is the rate at which the distance traveled is changing. So linear speed is the distance traveled divided by the time elapsed, meaning that it's S over R. I mean over T. That's the linear speed. What do you think an angular speed will be, guys?
It should be the red, the angle, the angle,
Yes, the angle.
in radians.
Yes, divided by.
Um,
Time elapsed.
Look at this. The linear speed is the distance traveled divided by T. The angular speed will be theta divided by what? By T as well.
oh,
Yeah. So the angular speed is the rate at which the central angle theta is changing. So the angular speed is the number of radians this angle changes divided by time, basically. So they say linear speed and angular speed. Suppose a point moves along a unit circle of radius r, and the ray from the center of the circle to the point traverses theta radiant in time t. Let s equals to r theta be the distance the point travels in t, of course. Then the speed s is, remember, we are moving along the circle. Hey, the way I like the unit circle, because here we don't know what r, we are moving along a circle or the circle. I don't know, my English is yeah. But you're moving on a circle like this. You don't know what r is. So it's not really, so meaning that that theta s is equals to r theta be the distance the point traveling time t, then the speed of the object is given by this. So there are two speeds of one object. We have the angular speed and we have the linear speed. Are we all together there?
yes.
Do you see the formulas? So angular speed is like something like this. What is this? It's not omega. I don't know what it is. And this v. Let's say WV. Now, can we look at this and think? I need you to think here. I need you to think, please. I need you to think here. I'm giving you 5 minutes to think on this one.
On which one, ma'am?
On this example.
Okay.
Have you thought about it? Guys,
Yeah.
can you discuss it?
Oh, this guys, I thought we were working out on our own.
No, you can work it out. But I want us
Okay.
to discuss it.
You want us to discuss it here?
Yes.
Yes.
Okay.
What do you think? Because I need to see your thinking. Your thinking has to have changed by now. Or it's starting to change by now. I was hungry. I suppose I wanted to go and take a banana.
Okay.
Does 15 revolutions means 15 times 2 pi? Is it? I don't know.
Why are you saying that?
Because the measure of one revolution of a circle is 2 pi, I think. And then when they say 15 revolutions, I think it must be 2 pi times 15, which is 30 pi. I'm not sure.
You're correct.
But why is it 2 pi? That's my question.
Because one complete revolution is 360 degrees. If you convert 360 degrees to radians, you get 2 pi.
Oh, okay.
That's a complete revolution.
And then our time is 15 seconds per revolution.
It's 10 seconds.
10 seconds. 10 seconds.
Oh, Kolisile, you start nicely and you decide, I'll just write anything.
So we know our time, and now we converted our revolutions into what is it?
Well done,
into radians. And
into radians.
convert into radians. Yeah, radians. So that's the.
So now what are you calculating? First, you must tell us what you're calculating.
Are we not calculating the angular speed first? That's what they're asking initially.
Okay,
so if we have to write in the time, so we just use the angular speed formula to calculate that.
Which is?
Which is, I don't know that W thing, but it's read over time.
Okay, our theta and radians over time, yeah.
Yeah, that's how I did it. Wrong word. Yeah, so that's how you calculate. So in this case, it'll be like you already converted to rad, so it's 30 pi divided by 10.
10 seconds. 30 pi radians,
Yeah.
ne?
Yeah, radians divided by 10. So let's see.
Where do you get the 30?
Oh, sorry.
From multiplying.
Yeah, from multiply.
For multiplying what?
15 times 2
15
pi.
revolutions, ma'am, with 2 pi, the complete revolution.
Because there's two rads, is it not, ma'am?
Okay,
Yeah.
you're saying what? You're saying, so then you get what? You get that W is equals to 30 over 10. That's what you're saying?
Yes, ma'am.
That's wrong.
Okay.
We said it's 30 pi, Muslim.
30 pi.
30 pi.
Yeah, 30 pi.
Radians, because you cannot use our theta as an angle, must change it to radians. Isn't it what you say?
That's wrong. What if it's 20 pi? What is not 20 pi? That's wrong.
Is it not 2 pi because it's 360 degrees? Or is this the
2 pi.
conversion rate? Yeah,
I
it's 2
think
pi.
it's 2 pi.
But I'm saying it's wrong.
Why?
Why is it wrong, man?
Guys, you should be confident in your answer so that when someone says it's wrong, then you say, no, it's not wrong because of this.
It's correct.
If we go back to
15
the area of
times
a
2 pi.
sector.
Okay. Is there someone who doesn't understand what they're talking about?
No, ma'am, that is correct. 100%. There's no chika.
Yeah, it makes sense to me.
Okay, other people. Other people, is there someone who's saying, there's this voice I didn't hear today?
I don't understand, ma'am. I don't understand. I don't know how.
What is the radius in this case? Let's start there. What is the radius in this case?
First, I don't know how to convert revolutions to radians.
Okay, so this is how you convert them. Degrees to radians. You'll go through that. This is how you do. You have degrees. If you know it's 360, you say 360 times 1 pi over 180. So that's 360 times pi over 180 to give you 2 pi. Right?
Okay.
Now, we start there. And they're saying here, what is the radius? Good people, let's start there. What is the radius? What is the radius here?
Is it 3 feet, ma'am?
That's 3 pi. 30 pi.
The radius?
3 feet.
3 feet. Why are you saying 3 feet?
Feet long.
Why are you saying that?
Oh, it's one. I think it's 1.5. Because if it 3 feet long is the diameter of the circle, and then the half of 3 is 1.5.
1 minute. Take 1 minute. Whether you're taking a string of a shoestring or you're taking something, take something. Right? Take a string, or you're taking a belt, or you're taking a key with a key holder. Right? Or you are imagining having it, ne?
Yes.
In your hand. Do you have it in your hand?
Yes.
Now start rotating. I'm doing the same thing. Start rotating. What do you see? A circle. Do you see a circle?
Yes.
Yes.
Oh, yeah.
Are you all rotating? Do you see a
Yes,
circle,
we are
isn't it?
rotating this
Yes. It's 3 feet.
Now, well done. Do you see that? That's your hand. Don't rotate the whole hand around. Does it make sense, guys?
Yes,
What I'm
ma'am.
doing? Not the whole hand.
Yes.
But when you are rotating, do you see that where your hand is the center of the circle?
Yes, ma'am.
Yes, ma'am.
And then where the string is rotating, that stone that boy is rotating is the on the circle. So meaning that the length of the string is what?
3 feet long.
It's 360. It's a full circle.
It's 360.
Yes, but then the length of the string will become our what in this circle?
Our radius.
Thank you. I don't know if you saw that.
Yes.
So meaning that you were rotating and your hand was here. When you rotate that string, I was rotating a belt. I was rotating like this. And my hand was here. Now the length of the string is the radius. So that's 3 feet. So R is equals to 3. Are you all together?
Yes.
Now,
yes, ma'am.
so they're saying that he rotates 15 times every 10 seconds. Now they didn't tell us how many 10 seconds he did, so we'll assume he only did 1 10 seconds, isn't it? Now, when you are rotating, when you are talking about revolution, as they said, you're talking about one complete circle. So you start here on the XY, you go 1. That's what? 360. You go 2. That's another 360. You go 3. And then you do 15 times, right? And since it's 15 times, guys, someone is talking. And since we're doing with radiances, who's this?
Antonio.
Antonio.
Yeah, ne?
Leave the
Sorry,
class.
ma'am. Sorry.
Leave the class.
Sorry.
You just leave to leave the
Sorry,
class.
ma'am.
It's not personal. You just
Sorry.
leave the class and then we continue. We have
Sorry.
been doing this
Sorry, I
for so
forgot to
many
mute.
times.
Sorry, ma'am.
No,
Sorry.
we understand your emotions of hore o batla ifele. Uka, you know, uka sipila, my love. So that we
No,
enjoy
I'm at
math.
church. Sorry. I'm at church.
You see?
Sorry.
And then we continue with the love of maths because with or without you, we'll still be fine. So now, let's continue. So now, isn't that it's a boy, right? Isn't that he rotates 50 times? So the first rotation, it's what? It's 2 pi. So meaning rotating 15 times, that will be 2 pi times what? Times 15.
50.
That is the way the 30 pi comes in.
Ma'am, sorry to disturb you now.
Yes.
So you included the 3 feet long thing when you
I
rotate
haven't.
3 times.
Yes,
or you don't
because
include-
remember this is where your hand is, and when you continue rotating, you have radiuses. The radii. So your radius is 3 feet.
Oh, okay, thank you.
Yes. Do you see that? That's where the 30 pi comes in. Are we all together? And that 30
Yes,
pi
ma'am.
is our theta. 30 pi rad. Well done. And who's Xolisile? Was it Sandile? Yes, she explained this. Well done. So meaning that we are able to find our angular velocity, and our angular velocity will be like this. So it will be pi over t, which is 30 pi. So this is what it's in red, ne? 30 pi rad over t, which is 10 seconds. So this is equals to 30 pi, or not 30 pi.
3.
So it's 3, sorry. So this will be 3 pi rad per second.
Okay.
Are we all together?
Yes, ma'am.
Yes.
Now, to
Yes,
find the
ma'am.
linear speed, what are we going to do?
We're going to say V is equals to S divided by T, and our S is it 3 feet? Yeah.
Why are you saying 30?
No. Okay. Our
Aren't we also multiplying with our radius? That's where the radius comes in.
Well done. So
So
it's theta times r. We know our theta is what? 30 pi times r. Our r is 3.
Oh.
See
and once
that?
you have your S, you can figure out linear speed.
There we go.
Oh. I
So
made a
this is
mistake.
90 pi. So 90 pi divided by what? Divided by 9.
Divide by 10 with
by
9.
10. No, I'm dividing the answer.
Oh.
So then the linear speed will be 90 divided by 10, which will be equals to 9.
9.
Does it make sense now?
Yes, ma'am.
There we go.
Yes, ma'am.
There we go. And that's it. Are we all together there?
Yes, ma'am.
Yes, ma'am.
So now they say, okay, a relationship between linear and angular speed. If a point moves along a circle of radius r with angular speed this, then its linear speed is given by that. So meaning that if you have the angular speed, you can calculate the linear speed using that formula. Are we all together?
Yes,
Yes,
ma'am.
ma'am.
So look at the formula and say, a woman is riding a bicycle whose wheels are 26 inches. Let's call them centimeters in diameter. If the wheels rotate at 150 revolution per minute, find the speed in inches, I don't know those units, in which she travels. What do you think we're looking for here? Guys, what do you think we're looking for?
Linear speed.
Okay.
Yeah. Wait.
Where do we start?
So we
Why
have
are
the
we
diameter.
before that?
By
Why are you
multiplying the
saying we're looking for the linear
revolution.
speed? Because why are you saying we're looking for the linear speed? Let's start there.
Ma'am, don't we have the speed of the wheel which rotates at 125 revolutions per minute?
Okay. So that's okay, that's good.
We also have the diameter, but what don't we need the radius? So we need to convert that.
Divide 26 by 2.
So if you have, well done. So meaning that the radius will be 26 divided by 2, which is equals to 13. So meaning that since we are looking for the linear speed, and here we do have the angular speed, then what do we do?
Just multiply the radius with the angular speed.
Ma'am, I'm confused. Why are we dividing with 2?
It's because they say it's a diameter.
Okay. Thank you.
Yes. It's a diameter. That's why we're dividing by 2. Mm-hmm. So what is the angular speed then?
$16.25 a minute. Oh yeah, you must divide that by 60.
125 times 2 pi.
Let's start there. So that's angular speed is equals to what? This is 125 times
2
2
pi.
pi. What do you get?
250.
250 pi, isn't it? And we know angular speed is equals to theta over t, which is equals to 250 pi over 1 minute. Isn't that they're saying per minute?
Yes.
So meaning that this is equals to 250 rad. If you put rad here, you say 250 rad per minute. So then you have found the angular speed.
Okay.
Yes.
Would it be wrong if I converted per minute to say 60 seconds?
But then here, do you see they're working with minutes? That's the thing. They didn't talk about seconds. Once you convert it, you say 250 divided by seconds, then you get the whole wrong answer. Unless you change everything in seconds, because the rotation is per minute. And they want the speed also in minutes. So meaning that you were able to find this one, which is, what is this? This is 250, right? Pi. So meaning your R is 13. So this will be 13 times 250. Do you see that, guys?
Yes. Yes.
So that's the answer. No, we forgot pi. What am I saying? 250 pi.
I was just about to ask that.
Sorry.
I was confused for a second.
Because the angle is 250 pi. So that's the answer. Are we all together there?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So that's what we got. Okay, here they didn't show the steps on how they found the angular speed. Do you see that? They divided by a minute. That's why it's per minute. They first find the angle in red, then they divided the as that we did per minute, and then we got per minute. Are we all together there?
Yes, ma'am.
Yes,
No
ma'am.
problem.
Yes.
Thank you. There it is. So you just have to know 13 times 250 pi. In the exam, it will just be 13 times 250 pi. I won't do 10 comma something, whatever, because you don't use a calculator. Okay, I see here they want us to convert. So no, we're not doing that. No. Oh, we are done with this one. Any question thus far?
Ma'am, it's example 6, I guess. I'm stuck somewhere. Please go back there.
Yeah.
Like why yeah, sure, I understood this part whereby you had to calculate that. Can you please forward it? I'll tell you when, ma'am. Yeah, I understood that. But my confusion was here, ma'am. What was happening here? Why did you have to calculate S in order to... I don't know how to ask my question there.
You see that?
But like V equals S over T, so we had to calculate S in order to substitute it back to the equation.
Yes. For this one, it was easy to just calculate because we only had theta over T. Do you see that? Now, we were able to find theta from the question and solve. This one, we didn't have S from the question. And we know S is theta times R. So we took this theta times the R that was in there and then found that. That's why we had to calculate S. And then we substituted in the formula.
Oh, now I see it.
That's good. Any question from this one?
Yes.
Yes. What's the question?
Okay. My question is, I just wanna know the difference between the linear speed and the angular speed.
So the difference is that at the rate at which one is changing as you are moving along the circle. Like, for example, this one here. So the linear speed deals with, what's this? The linear speed deals with the distance traveled, meaning that it deals with this distance here on the circle.
Mm-hmm.
The rate at which this S is changing. That's the linear speed. Right?
I got
the
you.
Angular speed. Yes, sorry.
I was saying I got you.
Okay. Now the angular speed, remember, the more you are moving along the unit circle, the angle changes. For example, if I'm from here to here, the angle is somewhere here. Do you see that?
Mm-hmm.
Now, if I move along, now the angle is here. So meaning that the angle is like this now. If I move up to this point, then the angle is from here to there. So then we're looking at the angular speed, the rate at which this angle is changing. That's the angular speed. So the distance has to deal with S, the angle has to deal with theta, both you divide by T.
Oh, the difference is distance and the angle.
Yes, the other one is the angle inside. This theta over here. Yes.
I'm good.
Ma'am.
Yes.